Hello Internet and welcome to CodeBig. In this video, we will be going through promises in JavaScript. I hope I got you excited, so let's get started. Welcome back guys. Maybe you're new to web development, trying to pick up on the latest front-end technologies, or you're a seasoned web developer and you don't fully understand the concept of promises. This video is for you. So, without wasting any time, let's get started. Promises in themselves are not too complicated, but it can be a little hard to break into them. This is because promises are their own design patterns and they don't usually play along with the traditional patterns that we are used to. First, let's look at what is a promise. By definition, a promise represents an asynchronous task that will be completed sometime in the future but potentially isn't done yet. Sounds confusing, right? Don't worry. To better understand promises, let's take a look at an example. Let us consider an example of flipping a coin, where the desired outcome is a head. You know, when we flip a coin, we are bound to get either a head or a tail. From this, we can conclude that we end up with three possible states whenever we flip a coin, right? One state is where we get a head. And let's consider it as a fulfilled state because that is our desired result. The next is where we get a tail, and let's say it is the rejected state. And finally, we have a pending state. This happens when we flip a coin and it is traveling upwards in the air. What we make out of this is, when we flip a coin, it takes a second or two for us to get the result, and thus tossing a coin is considered an asynchronous task. This is exactly what happens when we write a promise as well. Our promise is run immediately, but it takes some amount of time for us to get the result, and the time may go from few seconds to minutes. Now that you seem to be getting a hang of it, let's look at some code, shall we? Let me real quick copy and paste a code snippet so we can dig deep and understand promises. Here, we have created a promise and assigned to a variable called flip a coin, and within the promise we have a variable called randomVal which is set to match.random. Basically, this variable will have a random value between 0 and 1 each time we run the function. In the next line, we have a setTimeout method, and all it does is run these lines of code after an amount of time we have specified here. So, to replicate a coin flip, I say first create a random value between 0 and 1. Next, wait for 3 seconds, and if the random value is greater than 0.5, then just return heads, else return tails. And all of this is happening within the promise method, which I have here on the top, and as you can see, it takes two parameters, resolve and reject. For now, let's skip it and just run the program. When I run the program, you see in the console on the right, we get pending initially, which means our coin is in the air, and then after 3 seconds, we either get a head or a tail. Let's try and break down what happened here. A promise is a JavaScript class, and its constructor takes a single argument, which is a function called executor function. If we real quick jump over to the V8 implementation of promises, you can find the link to it in the description below if you want to check it out for yourself. You see, on line 57, we have something called a promise set, which takes a couple of arguments. The first argument says it accepts a promise, which is basically an executor function. Next, we have a couple of internal arguments called status and value, which we see down here is set to 0 and undefined initially. And finally, we have onResolve and onReject. Switching back to our code, you see, we also have something called resolve and reject. So, our executor function accepts two parameters, resolve and reject. You can name it anything you want, but the community standard is resolve and reject. The code inside the executor function runs, and you call resolve when you have a favorable outcome and reject if something goes wrong. In our case, resolve is called when we get a head and reject is called when we get a tail, because the favorable outcome in our case is a head. Now we can go through our code once again. At first we have flipping a coin, which is considered an asynchronous task. So the sensible thing to do is wrap it within the promise constructor. Then we tell our promise constructor always accepts two arguments, resolve and reject. Up next, we create a variable which holds a randomly generated value between 0 and 1. Then we start a timer for 3 seconds, and after the 3 seconds we check if the random value is greater than 0.5. Then we'll tell it's a head and resolve it, else we'll tell it's a tail and reject it. Cool. Now you see we have a good understanding of promises. Let's now understand how it interacts with the surrounding context. One of the most important things to understand in promises is even though you have created a promise, the surrounding code keeps running. Here is a quick example. So in the updated code snippet, what I have done is added a couple of console logs, and let's just go through them once. So at the very beginning, we have a log that says I'm about to flip a coin. Then we have our promise which prints the result, and then we have a log that says I have flipped a coin. When I run it, see what happens in the output on the right. At first, we get I am able to flip a coin, and then we get I have flipped a coin, and after that result of the coin flip. Got confused? If you're new to promises, then you might not be expecting to see the result in this format, right? But the reason for the current result is, as you know, JavaScript is synchronous and our program is executed sequentially. Now, the first console log makes sense. Next, what happens is our promise is run, and since it is asynchronous, a timer is triggered, and we're not specifically telling our code to wait till we get the result from our promise. What happens is the very next line of code is executed, that is the last console log, and after that we get the result from our promise and we just display it on the screen. I know, the next question on your mind is, how are we waiting for the promise to finish? If you notice the code snippet, we haven't discussed this section of the code till now. So let's look at what that does. At first we have flipacoin.then. Then is a method on the promise that takes a callback function that will be run after the code inside the executor function of the promise calls resolve. Similarly, the catch method on the promise takes in a callback function that will be run after the code inside the executor function of the promise calls reject. So we know the variable flipacoin is a pointer to our promise, and we are chaining the then and catch methods on the promise to handle the resolve and the rejected case. As you see in the callback for both the then and the catch method, we are just console logging the values that we get from the resolved and the rejected, that is heads or tails. Along with these, we have one more method available that we should use to chain onto our promises, that is finally. This one is a bit different because it is run every time our promise has finished, either the resolved or the rejected state. Looking at the code, you can see that we have chained finally, and in the callback logged this is always run, and if I hit enter, you see we get the outer context console log, and then we go inside and wait for the promise to resolve or reject, and then whatever is the outcome, we see this is always run at the console at the very end. How cool is that? You think it might make no sense to have a finally method, right? But in real life, we will be using it to do calculation regardless of the outcome of our network calls. Now that you have a solid grasp of promises, you might be wondering why your colleague or your friend always told you to stay out of writing asynchronous calls or glorified it as callback hell. The truth is, writing asynchronous calls are easy, but handling them is a bit difficult if you do not know how to do it properly though. But don't worry, you will not fall into this trap now. The other thing about promise is that once you create a promise and store it in a variable, you can continue to append then catch or finally methods to it later on, even function has finished a long time ago. If I just copy and paste this section of the code and hit run, you see it takes 3 seconds of time and we get the appropriate result in both the cases. Next, let's look at chaining promises. What we have done here is chained different methods available to us onto flipacoin variable. But let's see what happens when we chain variable. You see, Once a hit run, we get the result and then we get undefined. This is because then method waits for the last promise in the chain, not the method before it. Since we have only one promise, the first method returns the appropriate result. It returns undefined. The same is true for chaining multiple catch methods. Now we have reached the final topic where we will be looking at the static helpers that promise class has to offer us. The first helper we will be looking at is the all method. And in this code snippet, you see we have three promises. 1 and 3 are resolved and second one is rejected. So if I run this, we see that the catch method is partially run because promise.all resolves only if all the promises within it resolves. And since the second promise in our example fails, we reject everything. Next, we will be looking into promise.allSettled. This is run regardless of the promise being resolved or rejected. So if I run this now, you see we get all resolved because all settled awaits for all the promises to either be resolved or rejected. Finally, we will finish the video off by learning promise.raise. This one is pretty simple. It just waits for the first promise in the array to resolve. If it does, the then method is run, else the catch method is run. This is the end of the video, guys. That is all you need to know about promises to start working on asynchronous functions in JavaScript. If you have any doubt, please leave a comment below. See you in the next video. Happy coding until then.